Hello guys, this is the third video about putting everything together, and today we're going to discuss about legs and eyes. So some observation first. Let's have a look at what we have here. I changed a little bit the shape of the box that was behind, so this is nothing else than the body control. And now when I move the body control, you can see that the neck and the head module are coming together because we connected them last time when we introduced the input space, the local space and the world space. And now the legs are coming together as well. So the legs are very simple to connect. If you have watched the head module, it's going to be very similar, but some observation will be necessary. So if let's move into here. So right now we have not that big. Right now we have a head, then we have a spine, and now it's about time to connect the legs. So while for the head we basically took the entire module and connected through input, local and world space the entire module. So basically we can have a rotation that looks either like this when the rib cage is connected. So when the rib cage goes like this, so the orientation stay aligned to the world space, or we can also have orientation of the head like that, where the orientation is in local space. So the way we did this in this way because the head basically spawns completely out from the rib cage. Okay, and what I mean by its motion is completely outside the rib cage. When it comes to the leg instead, we have to make some observation because the leg can move either in IK, so IK is going to be green, either in IK or in FK, and FK we're going to draw it dark green. We're going to see this now in Unreal. So, but keep in mind that the IK is usually performed in order to have to have this object here locked, which means conceptually this object here already has a space, which is it can be the floor or whatever you put the IK control to. So in reality, in order to achieve all the effects that we need, we only need to work on the FK side, FK spacing. But now let's jump into Unreal. Maybe it's going to be a bit clearer. So right now, when I move the spine, I get the intended behavior. Let me make this bigger. I'm getting the intended behavior when it comes to the legs, because the legs are planted to the floor. The reason why is detaching is because I have stretch to control. The legs are planted on the floor. So in this case, I'm quite satisfied on how the IK works. All right. So the only thing that needs to happen when it comes to handling the IK is basically parenting. Let's have a look at the hierarchy here. If you take where we left last time, the only thing you need to do for the IK is making sure that the foot control is children. Do it this way. The foot control is children of the global offset, and this allows us to take this thing and move it around, because the global offset, which is this the little circle, there is the main offset, which is the big one. This guy is children of this one, and then so this should represent your world space. So ignore the fact that we are in a world. This is like where your main motion should start from. Meaning that if you take these two IK controls and parent them underneath here, you should be able to get this behavior where, based off this world space, the green circle, we can perform and compute the IK from that point on. And the same goes for the pole vectors. So these pole vectors can totally be underneath here, and you can see that they are children of it. So if I select the knee control, foot control, the only thing that you need to make sure of is that these controls, which are the IK hips, are now children of the pelvis. So you can see that underneath the pelvis IK, if I move the pelvis, let me select it, where is it? If I move the pelvis comes, brings down the hip controls, okay? And same goes for the FK pelvis, which, as we know, is basically an offset that doesn't change the curvature. Let's have a look at that again, just to refresh ourselves. If I move the big box, the silhouette of the spine changes. If I move the yellow one, which is the pelvis FK, the silhouette doesn't change. So the hip for the IK just needs to be parented underneath the pelvis. And this is basically a way to have the IK moving the way and connected to the spine by only parenting controls right now. So there is not much, work done from a spaces point of view in this sense, because there is no need to. IK takes care of giving us a new space already. So when it comes to FK though, let me switch to FK. So if I remember correctly, we should have settings here and say left. Where is it? Left KFK. Oop, I flipped something here. Oh, I flipped the pole vector. It doesn't matter. When it comes to FK, if I were to rotate this now, you can see that the FK is behaving the way it's supposed to in FK mode. So the parent connection, it's moving, or the input space as we have called, it's moving the FK as if it was a children. So it's exactly, this leg here is exactly as if we were moving the head in this other way. Let me select headspace and put this back. So you can see that the spine, the end of the spine, being the input space of the head module, it's taking the head module completely with it as a children. And the same is happening for the FK leg in this case. Okay, so it's taking its children. Being the pelvis, the input space of the leg, is moving the leg completely in translation and rotation. Now, this is the kind of behavior that we may want to change. So here's what I said, what I mean by saying we need to implement whatever we have done on the head, we need to implement it on the FK side. There is no truly need to do it on IK. And by no means, I mean, if the animator requires the IK to perform live, to have an additional space, you can totally add it. It's the same exact procedure. In my experience, this is a feature that some people do implement, but is never being really used. So this is up to you. In my preference is basically to implement this behavior only in FK. And let's see how it looks like. So I added a leg space. We're gonna see this now in the graph. And let me turn now this off. Let me switch both legs in FK mode. No, not that, sorry, that. And let's bring everything back together. Okay, so let's move now, let's change the space. Now when I rotate this, you can see that these two legs here are moving, but only preserving the translation of the hips, not the orientation. And this is something that might be helpful when you animate Dangan characters. So I've seen many times this option being used when it comes to the legs, specifically for aerial things, or people being hanged or stuff like that. Because you can, by having the rotation locked to the world, this is what you can achieve. So let's see the difference again. And you can see that this is basically the same thing that is happening on the head. In fact, the implementation is very similar. So we have these two things, or let's take the leg space back, or everything. So both translation and rotation. This is the effect that you get when you're driving both translation and rotation. And this is the effect that you get when it's only, basically you're only aligning translation with the input space, and the rotation it's in world space, which is kind of nice effect. Okay, so how is it done? Is exactly the same as in the head module. So the first thing you have to do is take your FK controls and create a local space above. So these are all the FK controls. Sorry, I just rotated that for some reason. Let me put everything back to 0. It's a bit annoying. I selected too many controls. Okay, so you select the parent upper leg of the FK, 1, 2, 3, 4. This is where we left it. You create a space above, and the same for the right side, 1, 2, 3, 4. You create a space above. Then this is the local space. The local space, if I look at the leg module now, the local space is then aligned to the bone. But let's start from the inputs. The inputs, comparing from the leg module, the way we left it, I just added input space, local space, world space, and or into local. So it's exactly the same options that I've added for the head. But in the graph here, you can see that the input space, so this one, in the case of the head, was spine 11 here. In case of the leg, it's pelvis. So it's, let me show the bones. It's this object here. It's the pelvis space. The local space is this guy, is this object that you guys have created, and the world space exists underneath the group that we created yesterday called world spaces, L leg world space and R leg world space. And these two objects are simply children of this green thing. In fact, you can see that if I orient this, everything, it's oriented properly. So we still have the this behavior, but it's oriented to world space. Keep in mind that currently the world space is being rotated, so the matrix they are referencing to is oriented like this, because the world spaces are following this rotation. Okay. So how does it work? We specify the pelvis, the local space, Same goes for, so this is left and right. So there is L, R. In the module leg, what I'm doing is, the first thing I'm doing, if I'm in setup mode, I am snapping. I'm taking the transformation of the pelvis. Sorry, of the upper bone. So I'm taking this bone here, and I'm setting the initial space of the local space. So what these two nodes mean, this group where is it? Where is it? This group, now it gets completely snapped on top of the bone. And then I'm taking the same exact thing and I'm snapping the world space. So both of these two are aligned in the same position at the beginning. Everything else here is identical. And this is the setup event. In the forward solve, the only thing I'm doing is checking if does the user want to be in orient to local, or if this is true, I am projecting the space. Sorry, I'm projecting the orientation of the bone to the transfer space. So the local, where is it? This local space, it's both in translation and rotation. And if it's false, so you can see the branch here. If it's true, I'm taking translation. If it's false, I'm only taking if it's true, I'm taking the transform of it, so both rotation and translation. If it's false, I'm only taking the translation, so these two nodes are the same, but the rotation is now coming from the world space. So I'm projecting the parent of the world space onto the local space. I'm computing the matrix. The output rotation of that matrix drives the rotation of the local space. So if you follow this thing, it's local space, which means this transform here translates with the pelvis but rotates with the group that sits underneath here. And this is the behavior that you get when this is false. When we set that to true, and I'm gonna set that to true, because I keep repeating this. When we set this to true, now we have one leg where the rotation is computed against the world space, and the other rotation is computed against the local space of the pelvis. And this is the two behavior that you can get. So this is it for the legs. The eyes are much simpler, because while it's compiling, let me talk about the eyes. So right now, the setup, the way we left it, is that we have the eye. The eye has a joint, has a bone here. This bone here is driven by this control, which means when I move or rotate this control, this sphere rotates because the bone rotates. Then the parent space of this object, so is the FK control space, and this is my FK control. This object here, we built a system where this object here is aiming towards another control, a circle, meaning that when I move the circle up or down, the eye, sorry, this object here looks at that or that, and because the FK control is a children, this can either look like this or like that. Because the FK controls rotates, the eye can either look at that direction or that direction. Okay, so this was just a recap of what we did for the eye module. What this means is that, again, because we're implementing an IK behavior, the space is already being taken care of, these two controls. So the only thing you need to do is take the space, that is above the eye, which happens to be, so this group here. You take the space and you parent it underneath the last control of the head, which was this one, okay? And then what you do is you take the two controls that are in IK and you simply need to parent them underneath here, because these two controls, being in IK, already do represent the world space conceptually. And the behavior that you get is that when you rotate the head, the eyes are still looking at those. Now, this is for the eye module. At the very end of this series, when I'm talking about Skeletron, we're going to do some cleanup, and we're going to add an additional control on top of the eyes, which allows us to move both of them together. And over there, we're going to implement a tiny bit of an additional helper for the animator for being able to lock the rotation of that control towards the head, so the eyes are always pointing forward. So these two objects and the third additional one will be always in front of the head, or with this behavior where they are locked to the world. So I'm not doing this now because I consider that not being part of the eye module. The eye module, it's a self-contained module that only works on these two things. So you can build as many eyes as you want. So at the very end, when I'm going to clean up the rig and making sure that everything works, there will be an additional third control here, and that's where we're going to implement the final the final tweaks to achieve something that might help animate things. So for now, because I want to keep things consistent in terms of modules from a mental structure point of view, these two things, the only thing you need to do is parent the space of the FK underneath the last control of the head, and you can see that automatically these two objects here are pointing to that. That's it for today. Thanks.